To understand why vector databases are so revolutionary, let's first look at the problem they solve. What's wrong with traditional search? Here's a classic database. It stores information in neat rows and columns, perfect for organizing structured data. Now, if we search using an exact keyword like Apple, it works perfectly. The database finds the exact text matches and returns the correct results. Simple and effective. But what happens when our search is more about a concept than a specific word? Let's try searching for a crunchy fruit. The traditional database fails. It can't find anything because the words crunchy or fruit don't appear exactly in the text. It doesn't understand the meaning. This leads us to the fundamental question. How can we build a search system that understands concepts, not just keywords? The answer lies in a powerful concept called a vector embedding. Let's take a piece of complex, unstructured data, like an image of a cat. We feed this data into a special kind of AI, known as an embedding model. The model takes our cat image as its input and analyzes it, capturing its most important features and characteristics, its essence. And here's the magic. The output isn't text. It's a list of numbers. This is the vector embedding. This vector is a numerical fingerprint. It captures the meaning of the cat image in a mathematical form that computers can easily work with and compare. So what do we do with these vectors? We plot them in a high-dimensional space. For simplicity, we'll visualize it here in 2D. When we do this for thousands or millions of items, like pictures, sentences, or products, something incredible happens. The vectors for similar items naturally group together. All the cat images land in one area, all the dogs in another, and cars in a completely different one. This is the key insight. Semantic similarity becomes spatial proximity. Things that are alike in the real world become neighbors in the vector space. This organization is what enables a new, powerful kind of search. This is powerful, but how does it work with millions or even billions of items? This is where the vector database becomes essential. One way is a brute force search. This means you compare your query vector to every single other vector in the database. As you can imagine, this is extremely slow and simply doesn't scale for modern applications. A vector database, on the other hand, is built for speed. Instead of a brute force scan, it builds a smart, high-performance index. Think of this index like a highway system connecting nearby vectors. When a search comes in, it doesn't check every point. It efficiently hops through the index, rapidly zeroing in on the most promising neighborhood to find the nearest neighbors in milliseconds. Vector databases are the engine behind many AI features we use every day. Searching with an image, getting product or movie recommendations, document search that understands context, and even detecting fraud or anomalies. So let's put it all together. The end-to-end pipeline is simple and powerful. You start with your complex data, images, text, or audio. You feed it into an embedding model, which converts its meaning into a numerical vector. These vectors are stored and indexed in a highly optimized vector database, which allows for ultra-fast similarity searches to retrieve the most relevant results. Vector databases are the core engine for the next generation of AI-powered search and retrieval. They allow us to find needles in haystacks, not by what they look like, but by what they mean.